ISRO attempted to soft land on the Moon with Chandrayaan-3, which was launched on a GSLV Mark III rocket carrying an orbiter, a lander, and a rover. The lander was supposed to land on the lunar surface in September 2019 and release the rover. Unfortunately, the lander failed to land successfully, which led to the need for another mission to demonstrate the landing capabilities for the Lunar Polar Exploration mission. In 2023, here it comes, the Chandrayaan-3 mission. ISRO has made great strides in its ambitious Chandrayaan-3 mission, which seeks to prove its ability to land softly on the Moon. After the setback of the Chandrayaan-2 mission, ISRO has worked hard to fix the problems and is now ready to launch Chandrayaan-3 on July 14th. The main goal of the Chandrayaan-3 mission is to land softly on the Moon's surface without any damage. By doing this, India hopes to join the elite group of countries that have successfully landed on the Moon. The mission also plans to conduct chemical tests, collect useful scientific data, and contribute to the progress of lunar research. Chandrayaan-3 is made up of a native lander module, a propulsion module, and a rover, with the goal of creating and demonstrating new technologies needed for interplanetary missions. The lander will be able to land softly at a chosen lunar site and deploy the rover, which will do in situ chemical analysis of the lunar surface as it moves around. The lander and the rover have scientific payloads to do experiments on the lunar surface. The main function of the propulsion module is to transport the lander module from launch vehicle injection until the final lunar 100-kilometer circular polar orbit and separate the lander module from the propulsion module. Besides this, the propulsion module also has one scientific payload as an extra feature that will be operated after the separation of the lander module. The launcher chosen for Chandrayaan-3 is the GSLV Mark III, which will put the integrated module in an elliptic parking orbit of size 170 by 36,500 kilometers. Some of the lander payloads are Chandra's surface thermophysical experiment to measure the thermal conductivity and temperature, the instrument for lunar seismic activity to measure the seismicity around the landing site, and the Langmuir probe to estimate the plasma density and its variations. A passive laser retroreflector array from NASA is used for lunar laser ranging studies. Major science equipment on the rover is an alpha particle X-ray spectrometer and a laser-induced breakdown spectroscope for deriving the elemental composition in the vicinity of the landing site. The GSLV Mark III or LVM-3, India's most powerful rocket developed by ISRO, serves as the launch vehicle for the Chandrayaan-3 mission. Standing tall at 43.5 meters with a diameter of 4 meters, it has a liftoff mass of 640 tons. The GSLV Mark III uses a cryogenic upper stage powered by the C-20 engine, India's largest cryogenic engine, enabling it to carry heavier payloads. It also incorporates two S-200 solid rocket boosters and two L-110 liquid stage Vickers rockets for extra thrust during takeoff. Landing a lander on the Moon involves several significant challenges. These challenges include navigation and guidance, entry, descent, and landing or EDL, terrain awareness, propulsion and thrust, communication and command, dust and regolith, and thermal management. Navigation and guidance are crucial for accurately directing the lander to its intended landing site. The lander must autonomously determine its position, altitude, and velocity, making adjustments during descent for a safe landing. Precise calculations, sensor measurements, and real-time data processing are necessary for successful navigation. The EDL process involves transitioning from lunar orbit to the Moon's surface. During descent, the lander must withstand intense heat from atmospheric friction, decelerate from high velocities, and maintain stability. Managing atmospheric entry and descent dynamics is crucial to avoid excessive forces or instability. Terrain awareness is vital in identifying a suitable landing site and avoiding hazards such as boulders, craters, or steep slopes. Detailed information about lunar topography and surface conditions helps select an optimal landing site and mitigate the risk of failure or an unsafe landing. The Chandrayaan-3 mission holds immense importance for India's space exploration endeavors. By showcasing its technological abilities in lunar exploration, ISRO aims to establish itself as a prominent player in the global space community. The successful execution of a soft landing would mark a significant milestone in India's space achievements and pave the way for future lunar missions. That's all for today's episode, fellow space enthusiasts. Stay tuned to Eccentric Cosmos for more updates on the Chandrayaan-3 mission and other exciting developments in the cosmos. Until next time, keep dreaming big and exploring the eccentric wonders of the universe.